My name is Chris Cantrell. I'm here to tell you about an awesome new course I'm teaching at UAH through the Professional and Continuing Studies Department. It's called Object-Oriented Programming, a Multi-Language Examination. Alexa, turn lamp Chris off.
Okay.
Now I could have turned the lamp off myself. I know how to do it. There's a little button right up here, but what if I change lamps? What if I get a lamp with a new kind of switch, maybe a rocker switch or a lever switch or something they invent 10 years from now? I have to reprogram myself on how to change the lights. In this course, you'll learn about encapsulation, which is hiding the data, the private parts, behind an interface. We'll discuss how encapsulation helps with software maintenance over the lifetime of a project. We'll see how it promotes OO polymorphism, and we'll see what polymorphism means. And we'll discuss the cost of encapsulation. Cost in software, that usually means a performance hit at runtime. We'll look at the concepts and syntax in the different major languages like C++, Java, Python, and JavaScript. Now don't let the code scare you. You don't have to be a master of all these languages. Heck, you don't have to be fluent in any of these languages, but a basic understanding of some programming language will help you here. This is a course on concepts, and it is insightful to see how the different languages approach these concepts in slightly different ways. Today I'm writing software for the new Harry Potter zoo, and the zoo has normal animals like lions and birds, but it also has some very special animals like a griffin. A griffin is part lion and part bird. Object-oriented programming, you're probably thinking inheritance. I get the lion, I get the bird, I get them together, and they make a griffin. And a griffin is a lion, and it is a bird. It has all the things that lions have, and it has all the things that birds have. In this course, you'll learn about inheritance and about class hierarchies. You'll see how one object can inherit from another. We'll look at multiple inheritance, one object inheriting from two or more parent objects, and we'll explore the diamond of death that can result. We'll separate inheritance into two main categories, implementation inheritance and interface inheritance, and we'll see what that means. Inheritance is the first OO concept that students latch onto, but the concept of composition is almost always a better solution. In this course, we'll discuss the difference between composition and inheritance and when to use each, but as a general rule, the famous Gang of Four recommends that you favor object composition over class inheritance. We'll be seeing a lot of the Gang of Four and their famous design patterns throughout this course. Object-oriented programming is a thought process. It's a way of thinking. It's modeling your problem with objects. And sometimes these objects are real physical objects like a domino or a tic-tac-toe board or a playing piece. But sometimes objects are intangible, conceptual. Take the object that finds the next best move for the computer player on the tic-tac-toe board. That's not something really you can grab hold of in the real world. In this course, we'll talk about modeling real-world problems with objects, and we'll look at a standard way of visualizing object-oriented systems, UML diagrams. That's Unified Modeling Language, and that's what you see here. When you hear OO programmers talk, it can seem like they're speaking a foreign language. By learning the concepts and terminology of OO, you'll be better equipped to discuss your own designs among your team and to read about designs in the literature and on the web. Throughout the course, we'll take a moment to tackle the lingo as we run into it. Alexa, show the link. Well, what do you say? Are you ready to join me on this crazy multi-language ride through object-oriented programming land? If you are, sign up at the link below, and I'll see you in class. Alexa, fade to black.